We are group number 7 and our project is HealthNow, which is based on the WebMD dataset. According to a survey conducted by NBC, which says us that 80% of internet users, or about 93 million of Americans, search for health-related topics of various symptoms and diseases online. This suggests us that internet plays an important part in educating and decision making for any particular symptom on concern. However, there is a lack of available web services online that can provide you interactive and intelligent analytics for understanding and making contextual insights. This is the core motivation for us to develop this application. The application Health Now is aimed at providing first-hand analysis to any general user before they actually go to consult a doctor. It would provide an interactive and intelligent healthcare portal which will be able to derive contextual insights based on the user inputs. While designing this particular portal, we kept three things in mind, which we also call the targeted deliverables for this particular system. The first being easy and effective user navigation throughout the whole dataset for any given input query. The WebMD dataset holds for open discussion forums on health related topics, and it's a huge dataset, and hence effective user navigation is very critical. We provide three different interactive visualizations that help you understand and better modify the query in real time. Based on the inputs, user can based on the visualizations, user can modify the query in real time. And at the last, we provide contextual insights on the various inputs. For example, what are the symptoms associated with certain disease or medicines? Or maybe what is the prevalence of certain symptoms or diseases over a specific period of time? These are the core deliverables that we are targeting to provide any user from this application.
To tag the symptoms, diseases, and medicines in our answer documents, we incorporate external datasets by WebMD and Columbia University. For every symptom, we fetch the documents that contain the symptom and maintain a dictionary of all the symptoms, diseases, and keywords with their values as the occurrence count or the confidence count with the current symptom. The dictionary keys for each symptoms, diseases, and medicines are sorted in the descending order of their values that contain this confidence count and in turn stored as values for each symptom in a master dictionary. This is done for all the symptoms so that when a symptom is selected in the front-end visualization, we only query for the top K symptoms, diseases, and medicines for that symptom from the master dictionary, which is stored as a local JSON file.
Okay, so coming to the overall interface of our application, we have provided over here a search interface that autocompletes and recommends the symptoms based on the user input. For example, let's search for dizziness. As you can see, the charts are updated based on the symptoms selected by the user. And also, as you can see from the below options, it autocompletes for you and recommends users certain symptoms. Let's click on dizziness. The chart is updated for as the query of the user based on dizziness. The network diagram dynamically showcases 10 most similar symptoms to the selected symptoms. It allows the user to interact and also modify the existing input query in real time. So when the user types dizziness in the search interface, it shows headache, nausea, and vomiting, and some of the other related symptoms. So if the user wants to see the results of nausea, he can select it from the network as well. The size of each bubble is proportional to the similarity score with the query symptom. We are also storing the previous history of inputs for easy navigation to the previous states. So let's say if the user wants to go back to dizziness, he can select it from the keyword history and go back. To the right hand side, we have a bar chart that displays the frequency of related symptoms, diseases, and also medicines for the queried symptom. The user can switch from one chart to the other with just a single click on the respective tags. That is, we have symptoms, diseases, and medicines. To the below of that, we have description section which describes the selected symptom very briefly. We have extracted this information from the Wikipedia pages available over the internet so that users can have a very basic understanding of the symptom or disease they are searching for. In addition to this, if users want to know more about symptom they selected, they can click on the more info which will lead them to the Wikipedia page of that symptom. And lastly, but not the least, to the bottom, we have used a time series chart to display the annual trend of the queried symptom and the related symptoms. It is helpful in gaining the confidence about given symptoms over a specific time. For example, if I search fever, as you can see in the time series, people are talking about fever a lot during October. So, it is not abnormal if you are also suffering from fever at that time of the year, as it is evident that a lot of people suffer from fever at the beginning of winter. Also, we have provided an option to zoom in and zoom out from the time series chart. This allows a much more detailed analysis and understanding of the prevalence over a particular time frame.
So, while developing this project, we thought for following criteria for the visualization. First is we thought about interactive and effective user navigation. So what we want for this project is that we wanted to develop a portal so that even if when a layman visited our portal, he could easily navigate and understand what is going on in this project. Second is what we wanted is an interactive visualization. So we wanted to involve the user as much as possible. So for this, a user can click and modify the query according to what he wants. And the third is like we wanted to have an intelligent system. So for this we performed various intelligent data analytics technique to generate the data. Also we used any external data sets for better results and more effective query. So right now this is what we developed, but we can extend this application to the future. We could add a geospatial data constraint in this application so that we could recommend doctors and the pharmacy according to the area in which the person is living. A person could select the location. For example, I'm living in Phoenix. I could select like what are the topmost doctors for a specific disease like cancer, or what are the topmost pharmacies in my area. So this would be really helpful